So welcome to today's video. For today's video we're going to continue our series, and so we're just going to have a quick recap for our last video. In our last video, we got the opportunity to actually create these dangerous spikes and then just set them up basically in our scene so that it can display in our game tab. And so I think that's all we did. And then we added a collider, but we did not um, find a way to detect collision in our game. So I think that is what we'll be doing for today's video or in this tutorial. Anyways, so I think this is filling the screen somehow. So these spikes now, I'm going to select these spikes. I'm going to change this view. Then I'm going to drag it up a bit, bit, bit. Yep. So I think this should be okay now. Let's see how that is looking. And that's okay. So collider still works. So right now what I'm going to do is go into my player, go to the movement, and then double click this movement so it opens up in Visual Studio, and I'll see you there. So if you're wondering what we're doing over here in Visual Studio, good thought, because over here now we're going to detect our collision. So we'll check to see if our player collides with spikes, and then we're going to call game over. So to do this, I'm going to go below my moving method, and then I'm going to type in Unity's way of detecting collision, which is void on collision enter, an open bracket. We will create a way to detect the collision, which is a collision. Call this call, and then let's open a squarely bracket. So this is just it, and then now what we want to do is check if it hits something. So with this we're going to use an if statement, and this would be if our call dot game object dot tag, call dot game object dot tag is equal to obstacle and we want to debug dot log. So if these two collide with each other, what we want is game over. So let's call this here. We want to debug.log game over. So let's save this now and go into Unity. So we can see now that my player is untagged, my floor is also untagged. So these spikes now is what I want to detect if my player hits. So right now we don't have any tag by default called obstacle. So the way we do this now is to go down here into add tag, then we're going to put this plus, and then we're going to call this obstacle with a capital O, obstacle, and then we save this. Then we can go back now into the spikes. You can see it appears here. So we now tag this as obstacle, override this. So this should be okay now. So if I should go ahead and play this game now and change this from project to console, let's watch what happens. We can see it debugs game over. So it prints out game over here in our console, which means it's working. So later on, we're going to replace this game over with a UI, which pops up for you to be to have a couple of selections on. But right now, we'll move into our next step, which would be to find a way to spawn in this floor or these cubes over here, which would keep going up. So let me delete the first, let me delete this cube and also this one. So let me select them and delete. So this should be okay, the player should be okay, the floor should be okay. Let me drag this up here so it looks more organized in a way. And let me create an empty game object. Let's call this restraint. Then let's drag these two walls into it. So this way our game is looking more organized. And so that's what we do now is that we create an empty game object. We call this our spawner. We're going to go reset this, and over here in my scripts folder I'm going to create a new C# script. I'm going to call this spawn. So let's double click this and go back into Visual Studio. So here in our IDE or Visual Studio, whichever one you like to call it, this is our spawn script, and just like any other script, we're going to start here by creating variables. So right now we want this game object to be coming off of different positions, or of a particular position, which is 2.5 on the X and roughly below the screen boundaries on the Y. So if I should touch this floor now, we can see it's minus 3.5. So I might set it to something like -4, -5. That's for my Y position. Anyways, let's go back into Unity, and first thing we would declare would be the game object which we want to be spawning in. So this would be our public game object. Game object, which would be our floor. Next would be a vector3 for our position. Vector3, we're going to call this pose, short form for position. We're not going to give it any variables right now. Next one would be a float, private. We don't want it changing in the inspector, so this would be a private float. Forgot the V. Private float. This would be our X pose, which would be by default I would set this to 2.5 F. Let's close this. Let's not forget the equal to sign. Next would be private private float. This would be our Y pose, which would be, let me set this to -5 F, of course. Let me not forget the unit. So this is okay, but then we're going to be using something called I enumerator. That's Unity's way of dealing with coroutines, and coroutines are basically methods or functions which are called upon but given a particular number of time which they can execute whatever line of code you call, and we would see that right now or later on. So let's first of all declare our float, another float. You know what, I'm thinking of making it public. Let's just use private. Let's call this also a private float, time to spawn, and this time to spawn, I'm not going to give it any variables right now because I want the time to be random. Spawn. So this is it. I want the time to be random, so we're not going to be editing it here in above our methods anyway. So we will do that in our update later on. And then finally, this would also be a private float. I really need to get used to this v. Private float, and this would be our timer. This also we would look at in our code. So for our void start, this we won't touch anything using our start method, or not anything that I can think of right now. So let's delete that so it does not occupy space. And then now to begin, we go into our update. What we want to do first here would be our vector tree pose. We're going to give this a position which is going to be our our transform. So this pose now would be equal to new vector tree. And this vector tree would be, let's say, random dot range for the x. This random value, we're going to put in a minimum and a maximum value, and the minimum value I want to use for my x right now would be minus 2.5, and the maximum it's just 2.5. So rather than use these numbers anyway, what we can do is replace this number with the variable which we have already declared up here. So this would be minus x pose, and this would be just x pose. And the reason why a lot of developers do this is because if there is an error, or if you would want to change the number anyways down in your code, rather than come here and start following each and every number and changing it, all you have to do is update it here, and then it follows every single line of code with it and it updates. So it's just a shortcut. I know if you're starting out making games, this may seem like a lot, but get used to using more of letters or variables than for you to use direct floats and integers and other other form of let's say numbers or figures anyway. So we've done this for our x position. The next would be our y position. So this would also be our y pose. And since we're not doing anything on the z, we can put it to 0. Normally, if we don't put this to 0, Unity can read this and then set it for us to 0, but just to be on the safe side, let's leave it at 0 right now. So we've created our pose. This variable now has some meaning into it, which is good for us. And the next one would be our time to spawn. So for the time to spawn, this also would be a random value for me. This should be a random also dot range. This range would be between 1 and 9. So there it is, we have our time to spawn right now. And what do we do next from here? First thing, or next thing we do after this would be to check. Now let me come up first and make declare our timer, so to speak. So our timer now above would be equal to, would be plus equal time dot delta time. Let's close this with the semicolon, not timer, time dot delta time. So this would be our timer. And next would be to create an if statement down here. So we can now check to see if our timer if this is greater than or equal to our time to spawn. And what we want to do now is to, of course, spawn our game object, right? So I think let me delete this. So this is okay. Now what we do is we're going to start a coroutine. The name of this would be spawner. Yeah, this should be okay. So below our update now, we're going to create this coroutine. This would be I enumerator. The name would be spawner, just like above. And inside here, first of all, we're going to give it a time which it's supposed to wait for. This would be our yield. Return new wait for seconds. And right now the time we want to wait for would be, let's use 1F. We could change this later on, but for now let's try 1 to see how fast the game object would be spawned in. So finally we want to give it the object which it's going to spawn in. So the way we do that is by calling on the instantiate. And then the first thing we put inside this bracket would be the name of the object which it's supposed to spawn in, that is floor. And then next would be the position for the floor, so this would be our pose. And for the rotation lastly, but since we don't want it to be rotated in any way possible, what we'll do for this would call on the quaternion dot identity, and this should be okay. So let's save this now and see what it looks like in Unity. And I have an error. Instead of wait, I put in R there, so let's change this to T and save this. It should be okay. And we still have an error for some reason. It should be okay for you, but for me personally, I think the reason why I'm getting this error is due to the fact that it's having a compiling problem in my Visual Studio. So I might fix this later on, and this should be fine for you anyway. So now with this cleared off and everything back to normal, what I'll do now is go into my spawner and I'm going to drag in my game object in. So I think this should do for now. Now let's play our game to see how it's looking like, or what it looks like. When I play this goes off 1, and something is still wrong. It's spawning in these game objects. It's spawning in quite a lot of game objects. So let's see. Let me reduce this. Okay, so what I actually forgot to do was you see this timer over here right now. If it's greater than or equal to time to spawn, then we should spawn. So this timer keeps going up, so it even surpasses my maximum value for time to spawn, which means it's always going to be true. So in order for us to control this, what we do now, after we start the coroutine, then we want to set our timer back to 0. So this would be equal to 0. So let's save this now and see it in Unity. So let's play our game now and see what it looks like. And okay, 1, 2, 3, 4, and they keep coming in bit by bit, which is good for us. So I think we've covered all we need to cover for today's video. Again, in our next video, we'll see how we can make things better or find a way to make this game more playable. That's reduce the level of spawning by destroying these game objects, and also we can create a game over UI hopefully in our next video. So thank you guys for watching this video. If you enjoyed it, give me a thumbs up. If for whatever reason you did not like the video, then you can comment down below so that I can find a way to maybe adjust it or repair the video in any ways. Anyways, if you haven't subscribed to this channel yet, make sure you do, and I will see you in my next video.